Okay. So, thank you. Welcome back. Today we're going to continue with where we left off last time. So, like I said in the other section, 1 week ago we were at below 25 degrees, and it's nice shorts. Frankly, for me, it's shorts weather right now. But last week we were not able to get the full H lecture in. I directed you to watch the other version of that because there is a little bit of overlap there. But the short story of it is that there are these 4 pillars of object-oriented programming. And the tutorial style demonstrations that I've been giving you up to this point have basically focused on abstraction and encapsulation. Abstraction being the information hiding, right? You don't have to worry about how data is represented, this object is represented. You just work with it. You don't have to know that that a date is represented with 3 numbers, or as a string, like a universal ISO 89, whatever it is, 8962, a string where you've got formats on it, or with respect to a Unix epoch, right? Unix measures time as the number of milliseconds that have passed since January 1st, 1970. And then the larger the number, the more the seconds in the future, the negative numbers go into the past, right? There are lots of different ways of representing time. You don't have to worry about that with object-oriented programming. You just have this local date time thing, and it's a black box. Whatever's inside that box, it gets the job done. Just like the square root function. How does it work? Does it use an interpolation method? Does it use Taylor series? Who cares, right? Just use it, right? It's a black box that operates, and you don't have to worry about those low-level details. With object-oriented programming, that takes another step toward, it takes procedural abstraction to another level where you've got object abstraction, and you only have to worry about the interaction of objects. With encapsulation, again, that's comprised of 3 things. It's the grouping of data into one logical unit, right? So you even have that weak encapsulation in C with structures. If you've got a person, well, a person is a first name, a last name, a social security number, whatever else, that's a person. All those things together should be grouped into one logical entity, so you don't have to worry about the little pieces of data floating out in ether. You can treat it as one thing, right? But it's also with the protection of the data from the outside world, using the keyword private, right, or protected, or public. Sometimes you use public, and then controlling access to the outside world through getters and setters and the constructors. 3, you don't have that in C. You only have weak encapsulation, number 1 in C. But you do have number 2 and number 3 in Java and most object-oriented programming languages, where you also group the methods or behavior that act on that data in the class itself. You would be breaking encapsulation if you located, say, a decay method or a deposit method, a decay method for an isotope or a deposit method for a bank account outside the class somehow, right? What would that look like? Here's the bank account class that we were working on last time, that you have an account number, an owner, and a balance. And what I've done here is I have added some functionality. First of all, I've taken away that set balance. Instead, if you want to change a balance in a bank account, what operations do you actually have? You have deposit and withdraw, right? And it would be breaking encapsulation if in my demo class over here, if I wanted to make a deposit, right now it's good encapsulation because the class handles it for me. Let's see, bank account, my Fidelity account right here. I'll make a deposit of, I don't know, $50. So it brings me up to $100 right there, right? It would be breaking encapsulation if I located that outside the class. If I had some sort of a public static void deposit method, where I took a bank account, A, and the amount that you wanted to deposit, amount, right? I took those 2 things and then I ripped open the class. I'm nowhere near the class right now, but if I ripped open the class and I said, give me your balance, and then I'll add this to it, and then I'll set the balance. So something like double current is equal to A dot get balance, right? And then double amount after is equal to current plus amount, and then set it back into the class. A dot set balance to amount after. Right? So let me go ahead and go back over here and restore that setter just for a second to show you what this looks like. Of course, I should remove the dead code after I'm done. Right? Does that seem right? Right? Setting a balance that outside the class, that requires you ripping open the class and grabbing the balance. Then it requires you to do the business logic. It's not heavy lifting right here, right? It's just addition. The old balance plus the amount you want to deposit. That's the new balance. And then you rip it open again so that you can set a value inside of it, right? This is what you would do in C because you have to, because you don't have good encapsulation. You don't have the grouping of methods that act on that data. And so in a programming language, a non-object-oriented programming language like C, you do have to do something like this. But in an object-oriented programming language, it's icky. You don't want to do that. You want to locate functionality that acts on the data of a class inside the class like this with a deposit. Because then you can also do other things like, well, if you ever try to do an illegal deposit, like a negative deposit negative $10 into my account, well, you're trying to withdraw money then, right? And you should be calling the withdraw method instead. And so we'll throw an illegal argument exception here. Deposits must be non-negative. Likewise, with withdrawals must be positive. I went less than or equal here because it doesn't really make any sense to make a $0 withdrawal. Maybe it makes sense to make a $0 deposit. I don't know. You can always change that, whatever your business logic is. But also, if your balance, the amount that you're trying to withdraw is greater than the balance that you have in there, you'd be overdrawing, and you can't overdraw this account. So I'm going to throw that back at you with an exception. And locating all of that stuff inside the class means that class, this is a bank account class, it's responsible for bank account things. Right? It's not we're not taking that responsibility and putting it outside the class. Also, it's not responsible for things that are not bank account things. Right? We've got good encapsulation and good composition here. Right? We've got a person, and we've got well, we didn't do it here, but I guess an address. Right? Oh no, sorry, we did. A person, it has an address. Right? There's the address, and there's date of birth, et cetera, et cetera. The bank account is not responsible for that kind of stuff. It's not responsible for person stuff. Person stuff, like first name, last name, that belongs in the person class. So a separation and isolation of responsibilities. Bank account classes should be responsible for bank account stuff. Address classes should be responsible for address stuff, etc. Question?
For abstraction, I'm confused. Is abstraction just like people shouldn't know to put like 3 integers into this function?
Right. You should not put the cognitive. Abstraction. The question was on abstraction. You should not put the cognitive load on the user. So here's an example. Let's go into the person. Remember, we had the date of birth. How do we represent a date? Is it 3 numbers, 3 integers, the year, date, month? Is it a string? Is it just one number from an epoch? Who cares, right? We just know how to use this stuff. And if we want to, we can compute like the difference between 2 dates. So the date that this course started and today's date, how many days have passed? There's lots of complex math in that, because is it a leap year, right? I mean, it's been, say, over a month. Well, did this month have 28 days or 31 days or 30 days, right? All those little details are abstracted away. We don't have to worry about it. We can just take a local date, add another local date, and ask the library, what's the time between these 2 things, right?
So it's like for the square root function, it would be like I don't have to wonder whether I should be putting an int or a double.
Well, you do have to worry about inputs and outputs, right? Because if you give it a negative number to the square root function, you would expect it to raise an error of some sort. And so there are, this is a black box, but the black box does tell you its expectations, right? With respect to the documentation. That if you did give me a negative, there was $100 in the account and you tried to withdraw 1,000, I'm throwing that back at you as an error, right? right? So there is some back and forth. You give me input, and I have expectations on that input. If those expectations are not met, I throw an error. You give me good input, and I will give you good output, right? So there, that input-output is there, but once you give me your input, your job is done. Now it's my responsibility to figure out all those details, and I'm inside the class. I'm protecting you from having to worry about those details. A pitfall would be like a leaky abstraction, and I think that we did that with the emails last time, or maybe it was something else, where you don't have to worry. You just need to know that a person has emails. You don't need to know that they're a set of emails, or a list of emails, or a tree of emails, whatever, right? You just have emails, right? And down here, I can add an email by simply giving you a string, and then it's this class's responsibility. The person is responsible for person stuff, for how to add that to the collection, right? So it's a separation of responsibilities. You shouldn't have to worry about the inner workings of a class, and that's what abstraction is all about, right? All right, so the other, like I said, there are 4 pillars. Some people say there are 5 pillars because, of course, there are objects, but that's what we started with. And also, there's no 5-pillared buildings, right? You just have to have 4 pillars on each of the corners. So abstraction and encapsulation. Inheritance is what we're going to start talking about today. And inheritance, basically, it's a mechanism that allows you to do even more code reuse. It's a mechanism by which objects can be extended, and that's italicized there because in Java we use the keyword extends in order to do this. And you inherit state from its parents. So you've got a parent-child relationship. And if you've got this parent up here and it's got a bunch of functionality, you can go ahead and extend that down to a child class, and all that functionality can be reused in the subclass. But then once you're in the subclass, you can start extending or augmenting or modifying that functionality, okay? And again, it provides a way to reuse code, but it also provides a way to organize code. And for that, I'm going to have to open up my iCloud here, sorry, to pull up all the other figures that I want. Let's go. I just started using iCloud because I got an iPad, but then I forgot my cord today, so we're going to have to go with this instead. No, that's not the one I want. Here's something that you're already familiar with. Here's a truncated diagram of the collections library. Right? Now this provides a hierarchy, right? And it's what's called a single inheritance hierarchy, because we have one root, and any child is the product of one parent. So it's not like a family tree where you've got 2 parents creating a new child or children. In fact, that's not a tree. That's a lattice or a mangrove or something like that. So it's actually, a family tree is a misnomer because you have all these other branches coming in, and it's not a tree with roots going out to these leaves. Not only that, but in computer science, our trees are weird, right? How do they grow? They grow downward, right? Why is that? Well, it goes back 300 years or so to Cayley, who first started talking about these things. And we like our trees to grow downward. Why? Because in English or most Western languages, we read top to bottom, left to right, and our trees represent things. So we're not going to read backwards, bottom to top. That's why. Question?
No, I was just going to say, because we generally don't like sunlight as people who work with computers.
Oh, okay. Anyway, the hierarchy here, you should be somewhat familiar with, right? At the very top, we have the most abstract notion at all. It's collections. This is a bag that holds things, right? That's as general and generic as it gets. Then you can have lists and sets that provide more specificity, more specification. Abstract up here, a little bit less abstract down here. What's the difference between a list and a set? Order, right? A set is unordered. A list is ordered. So a set is something that holds stuff, right? It's inheriting that behavior or aspects from its parent, but it holds stuff in an unordered manner. A list holds stuff, but it holds it in an ordered manner. Now let's zoom in on this list over here, just this part right here. What's the difference between an array list and a linked list? Well, we haven't talked about linked lists yet, but it's the way they hold stuff in order. But an array list is a list, and a list is a collection. A collection is just a bag that holds stuff. A list is more specific in that it holds stuff in an ordered manner. And an array list is even more specific. It holds stuff in an ordered manner using an array. A linked list is a collection that holds stuff in an ordered manner, but using a bunch of nodes, a bunch of connected nodes instead of an array. So the most abstract ideas until you get down to the more concrete ideas down here. At each part, you are inheriting behavior. You are inheriting aspects of the parent, right? And also it provides, the other justification for this is it provides a way to organize code. Right? This kind of tree structure is used all over the place in order to organize things into a hierarchy. Think about biology. We couldn't think of the acronym today. King Philip, anybody remember it? Oh, did King, domain, thank you. Domain, kingdom, phylum, genus, order, species? Did King Philip, what's the rest of it? Come over from Germany. Family, genus, order, species. Whatever it was, right? So we've got this whole hierarchy in the natural world. Why? Because Earth's biosphere is so complex that we can only make sense of it if we start organizing things into different categories. You can talk about all reptiles over here and all mammals over here. All mammals have some common trait, right, that distinguishes itself from all reptiles over here, and likewise with reptiles over here. And creating a hierarchy like this allows you to organize your code and your classes, that all collections hold stuff. A set holds stuff in an unordered manner. A hash set holds stuff in an unordered manner that uses a hash table under the hood. Right? So it's for organization as well. Organization and code reuse. In Java, we use the keyword extends to do this. So in Java, we use the extends keyword to subclass classes. Right? If we've got a situation where A extends B, then we say that then A is the subclass or child class. Sometimes these are the derived class, a whole bunch of different synonyms that you want. The subclass is good enough. Of B, which is the superclass or parent class, right? If you want to use that metaphor, whichever one makes more sense to you, okay? Extension or subclassing defines an is a relationship, right? And I'm going to show you one other diagram here. Ignore the keywords contravariant, covariant, and invariant for a second here. But this is even simpler to understand because it doesn't require any code whatsoever, right? We've got robins and ostriches, which are both types of birds. So I'll ask just from an English biology perspective, is a robin a bird? Yes. A subclass is its superclass. Is an ostrich a bird? Yes. Is a bird necessarily a robin? Nope. So the relationship goes up. The relationship does not necessarily go down. If I've got an ostrich that is a bird, well then that bird is an ostrich. Right? It can be treated as an ostrich. But can you ever treat an ostrich like a robin? Nope. Right? Like I said in the main section today, one of them tastes good and the other one does not. Right? I've never tried to eat a robin, but I don't think that anybody serves robins, kind of like the rats of the sky. But you can certainly eat an ostrich burger at Fuddruckers. I think Lincoln has a Fuddruckers, don't they? All right, well, look it up. Certainly there are Fuddruckers up in Omaha if you want to. You can get a buffalo burger. You can get an ostrich burger. I think you can even get an alligator burger. But I'm not sure on that. But you can get those kinds of grounds meats. Right? It's not that much difference. So it's a little bit of novelty, but there are differences there. It only works one way. An ostrich is a bird, but a bird is not necessarily an ostrich, and certainly an ostrich is definitely not a robin. We have words for this. This is a covariant kind of conversion, that a robin can always be treated as a bird. This is a contravariant, where if you can try to treat a superclass like one of its subclasses, that may be safe if you originally started with an ostrich, promoted it up to be, or made it into a bird somehow, and then forced it to become an ostrich again. Well, yeah, it started out as an ostrich, that would be okay. But if you started out with a robin, made it into a bird, and then tried to force it to become an ostrich, that's definitely not going to work. That's definitely an invariant coercion type. You cannot convert a robin into an ostrich. Okay. So now let's go back to our code, and I've got a bank account here, but so far the bank account is just the account number, the owner, which has an address and a bunch of other information, and a balance. I can, of course, make deposits and withdrawals, and here at this point I'm going to go ahead and get rid of this. And I'll necessarily have to get rid of this over here in the demo as well, because that's bad encapsulation. But there are many types of bank accounts, right? Is there such a thing as just this bank account, this generic bank account? Can you go to a bank and say, "I'd like to open up a bank account today"? Are they just going to say, "Sure, sir, we'll go ahead and do that"? Right? No, what are they going to do? They're going to ask you, "What type of bank account do you want? Do you want a checking account, or do you want a savings account, or do you want an IRA, a retirement account? Do you want what's the opposite of all those? Those are all deposit accounts where you're putting money into the bank. The other type is a loan, right? You're taking things out of the bank, right? So what is this bank account? I don't know. We need to be more specific here. So I like those first two ideas. Let's go ahead and create a new checking account, right? Checking account type. At the same time, let's go ahead and create a new savings account. Right? We can add an IRA later on. We can add loans later on, but let's just go ahead and stick with these two for now, because it fits in with the diagram that I just showed you. All right, well, what's a checking account? A checking account is going to have an account number, an owner, and a balance. That's a savings account. What's a checking account? Exact same thing. But in addition, with a savings account, why are you motivated to put money into a savings account? Pays you interest, right? Double APR. And we'll just say for now that it's 5% interest on a savings account. Right? But also, checking accounts also sometimes pays interest, right? It's just that it's my actual Fidelity checking account right now, or money deposit account, is only earning 0.01% interest. So 5% is represented by 0.05, and this would be 0.01% interest. You're not going to get anything out of that, right? But wait a second, what was I doing that entire time? Copy, paste, copy, paste. Sound like a good long-term strategy, copy pasta? Nope. What do I have in common here? A savings account is a bank account, and a checking account is a bank account. Right? And there's commonalities here. We've got an account number, an owner, and a balance. Well, I don't need to repeat myself, DRY principle, don't repeat yourself, if I extends bank account. Now by doing that, there's an error here that we'll get to in a second, but by doing that, all of this stuff up here in the bank account, the account number, owner, balance, as well as all of the behavior, is inherited by the subclass. Right? Now let's fix that before we move on. What's it complaining about? I need to add a constructor. Right? Because if you're going to create a robin, to create a robin, you need to create its bird aspects. All birds have feathers. All birds have beaks, I assume. I'm not a biologist. or birdologists, whatever they want to call it, aviologists, whatever they're called. But I assume that all birds have beaks, right? So in order to create a robin, you have to create the bird aspects of it first, and then you can create the robin aspects of it. So to do that, I'm simply going to let it do my work for me. There are no checking account aspects to this, except for maybe the APR, right? I could set the this.apr. Oops. This.apr. We could take that as part of the input if you really wanted to. I'm just going to hard code it for now, right? Would it make sense if I did the APR first? Can I create a robin and create the robin aspects first and then create the bird aspects? No, remember that is a relationship. A robin is a bird. So it has to be a bird before it can be a robin. So we have to, and you can see it here that it's not compiling because when you call a superclass constructor using the super keyword here, that has to be first, period. Right? You have to create the aspects that are getting inherited before you can create the aspects of the subclass. And in this case, that's just APR. Right? Same exact thing over here. If I extends bank account. And by the way, why am I doing bank account from both of these? Is a checking account a savings account? No. Is a savings account a checking account? No. I mean, you can tie them together somehow in some banks and they don't make make a distinction, but we're going to make a distinction here. Right? So I will go ahead and generate this constructor as well. Put that back up there. And I will set this APR to 5%. This.APR is equal to 0.5%. There we go. Always get rid of your to-dos once they are done. Right? Don't leave dead code in your final submissions. Okay. There. Now over in demo, I can be more specific. This, in fact, is a checking account. And I can create my Fidelity account as a checking account. Or I could leave it as it was. That is, what kind of variance is that? It's a covariance. It's always safe to treat a robin like a bird. And so over here, it is safe to treat a checking account like a bank account because it is a bank account. Because of this extends keyword right here. Likewise, did anything else break? I'm still able to deposit. I am still able to print it out, and it still works. Right? There's my bank account. There's $100 in it because I started out with 50. I deposited 50 more, and it's owned by me. Right? So it certainly has an owner. It certainly has the owner has an address, et cetera, et cetera. Yeah, question.
Does it necessarily have to be a checking account or a savings account? It's like
I still am able to do this, right? Which seems like a flaw in my design. The whole reason that we created checking accounts and savings accounts was because we didn't have this notion of a generic abstract bank account, right? But I'm still able to do it. That seems like a design flaw. So how can we address that? Say what? Oh, okay. One thing we could do, that's a good idea. One thing we could do is we could make this constructor private. And that prevents me certainly from doing it in the demo over here, but it breaks a whole bunch of other things. The subclass can no longer call it superclass because when something is private, only the class can see it. So what's another keyword that we haven't talked much about yet, but I could make it public, right, like I had before, but now we're back at square one. That's allowed over here, right? What's something in between? Public, everybody can see it. Private, only the class can see it. What I want is, I want the class to see it, but I also want its children to see it. And the way that you can do that is protected. Right? That's the in-between keyword. Now over here in checking account, no, yeah, you can see that super constructor there. In fact, you can see anything that is protected. Just to show you what I mean by that, this dot, I don't know, balance. I don't want that balance is equal to 42. Right? I can't see that in the subclass here, even though it's there. I've inherited it from the bank account, but that's because it is private. The second that I make this into protected, now you can see it over here in the subclass. So protected is an in-between between those things. But the argument here for particular for balance would be, it's in the superclass, you have a getter for it in the superclass, there's no reason to make it protected. You don't need it in the subclass if you can use the getter to access it. So I'm going to leave this as private. But that certainly is one way of doing it, public. Right. Get rid of this. Yeah, over here in demo, I'm still able to make a generic bank account. Yeah, go ahead.
What is the better practice? Is it like using getters or?
Good question. The best practice is to limit the scope of variables as much as possible until you absolutely have to, right? So private, getters everywhere until you have a case where there's no way that I can do what I'm trying to do without making it, without opening it up a little bit. And so at that point you say, okay, fine, I'll go back and make it protected, not fully public because I still, protecting it is still my goal. But now I need to make it protected so that I can use it in the subclass.
Is it like a good alternative to like, or it's like the same as having a setter and a getter, which are protected, which is like, or you could just like one protected variable.
Yeah, I mean, you can go many different ways, but in general, you want to follow the directive of limit side effects. So if you shut off, well, it's like security. I mean, there's no way it provides security doing it like this. It's just security as far as design is concerned, but like a firewall. So if you want good security, you firewall every single port. But then somebody calls you up and says, I can't get to a Facebook anymore because you blocked out port for SSL would be 443 or something like that. Okay, fine, I'll open that one up because there's a use case for it. But all the other ones, I'm still going to lock them down until somebody else says, well, no, I've got this client that I have a need to make a connection to an SSL or SQL server. So, okay, fine, I'll open up port 3306. Right? All the other ones still are, or actually, I'll only open up port 3306, but only for that server over there. Right? Still want to limit as much access as possible, and that should be the design principle that you follow. Right? Until there is a very good reason, capital V, capital G, capital R, to do so, make everything private. Right? All right, so one solution would be to make this private or protected because we have to. Another solution would be, is there really a concept of a bank account? I'll turn that around and say, is there really a bird? Right? There's robins, sure, and a robin is a bird. There's an ostrich, sure, but an ostrich is a bird. Is there really a bird? You get the same reaction going to your banker and saying, I want to open up a bank account. All right, well, what type of bank account? You go to, is it ornithologists? Are bird people? I don't know. Anyway, you go to a biologist and say, I'd like to see a sample of a bird. Are they going to be able to give you that sample of a bird? No, they're going to have to give you a sample, like here's a robin, here's an ostrich, here's an ortolan, right? They're going to have to give you a specific type of bird. There's no such thing as a bird, right? And this goes to some of the philosophy behind this kind of programming language paradigm. If you're familiar with Plato and the Republic and the allegory of the cave, right? I think that's standard high school fare, right? Everybody's heard of allegory of the cave. Maybe they forgot about it. No? Okay, well then you're going to learn some philosophy today. So Plato's idea of the allegory of the cave was that humanity is blind. They don't see the real ideals of anything. Instead, he said humanity is like a bunch of people sitting in a dark cave. And behind them is the fire. And so all they ever see is shadows of themselves. All they ever see is shadows of reality. Everything else is an illusion. And the idea behind that philosophy is that there is an ideal of anything. There's an ideal chair. There is an ideal whatever. There's an ideal bird. It's just that we never see them. We only see shadows. We see the robins. We see the ostriches. That might seem like frivolous philosophy until you think about it mathematically. Is there such thing as a perfect circle? Hypothetically, good. In other words, you can mathematically describe the perfect circle using this symbol pi. But pi goes on forever. Can you ever write down pi? No, because it's an irrational number. It goes on forever. Can you ever draw a perfect circle? No, there are going to be little tiny, variations, right? Not even the best artist in the world can draw a perfect circle if you measure it everywhere. Can a computer draw a perfect circle? No, why? You zoom in far enough and you realize that it's just a collection of pixels, right? Mathematically, you can describe the perfect circle, but there doesn't exist the perfect circle. You could describe a bird, but you would be describing an abstract idea of a bird. You can describe a bank account, but you'd be describing an abstract idea of a bank account. So if you're going to talk about abstract things, you can talk about abstract classes. An abstract class is just it's a class that provides that you can have state, concrete state. You can have some methods here that are that are concrete, that the getters, the deposit, the withdrawal, that all still exists. But you can now no longer create a bank account, right? I'm prevented from creating this thing. I have to say that this is a checking account, or that it's a savings account. I can treat it as a bank account. I can treat it as the abstract idea of a bank account, but I can't create a concrete instance of an abstract idea, right? Just like you can't do that with a circle. Yeah.
So you're more like distinguishing between like types, I suppose, in the objects itself.
Right. Well, the hierarchy definitely distinguishes the differences between those two. Now, so far we haven't designed any differences, right? Both have an APR. So give me a difference between them. One difference might be, and unfortunately I'm going to have to look at my notes here because say that is how you compute the interest on an annual basis. So public double get annual interest. Right. Savings accounts, they don't pay well. What do I have here? Check it. So suppose that it's only compounded, say, monthly, though, right? That is this APY. Given the APR, you divide it by the number of periods each year, in this case 12 months, so monthly compound. Then you raise it to the power of 12, you subtract 1, and that's how much money you get each year. Right? So let's translate this to actual code now. Math.pow of this part raised to the power of 12, there we go, minus 1. And that's the APY, the annual percentage yield. This APR is annual percentage rate. And then we multiply that by the balance, this dot balance. Of course, since I've made it private and I have and allowed access through this getter method, there's no reason to make it protected. So if I don't have a very good reason yet, then let's go ahead and keep it as private. Because I'm able to get the job done without exposing it any further. And I'll return this. Okay? That is monthly for checking accounts. Or for, actually, that's for, I intended that for, no. Okay, we could go one way or the other. I'm not a bank, so, the fewer number of periods, the smaller this number right here, the less they actually have to pay you. So let's go ahead and go with, I don't know, just once a year, or that'd be kind of stupid. So let's go ahead and go with 365 here, and 365. Generally, checking accounts are monthly, and savings accounts are also monthly. Of course, if you turn that around and you have a credit card, guess what? It's daily. You're paying interest to them, so they're going to compound it more because that means that they can get more money out of you. on interest. So this is kind of like a credit card right here. Very, very generous checking account. Except, of course, that the interest rate is absurdly low and we're not going to get anything out of this anyway. Okay? So I have different behavior, right? Over here with my bird example, all birds move somehow, right? How does a robin move? It flies, right? Does an ostrich fly though? No, they're too heavy. That's why we like them for our Fuddruckers burgers. They got a lot of meat on them. So an ostrich walks or runs. I think that they are quite fast. But anyway, in any case, every bird moves, but they move in a more specific way. Every bank account gives you interest, but how they do that, the APY formula you use, is different for each type of bank account. Okay? So let's go back over here to my demo. And I've created a savings account. Let's also go ahead and create a checking account. Right. I think I did Wells Fargo before. Fargo, there we go. And a different account number, 1222. There we go. And I've got, I don't know, $42 in it, right? And I'll keep my deposit up there. And let's print this out and make sure that it works. Awesome. Wait a second. Checking accounts. Did I specify that the toString method? No. Why? Because that was already done in bank account. Again, it goes back to code reuse. I only have to write this method once, and if I don't want any changes to it, all subclasses can inherit this method. Okay? So let's go back over to the demo here. I want to know how much interest am I going to get total this year. I've only got 2 accounts. So I could, ask, well, savings account, my Fidelity account, how much interest from you? My Wells Fargo account, how much interest from you? Or I could put it into a collection, a list of bank accounts, checking accounts. Let's try it this way first. My accounts is equal to new ArrayList. There. Can I add both of those counts to this list? My accounts dot add my Fidelity account, and do that again for Wells Fargo. Can I do that? No, why? Oh, is it? No, Wells Fargo, right there. Wells Fargo and Wells Fargo. There we go. Yep. It's not even allowing me to do either. Why is it not allowing me to do a Wells Fargo account, which in fact is a checking account? It's because I'm treating it like a bank account. Okay, fine. I'll treat it like the subtype. Now it's fine. But can I add my Fidelity account, which is a savings account, to this list? Nope, this list is only good for what? Checking accounts. I want to collect all of my accounts into one location so that I can iterate through it and add up all the balances, or I can add up all the interest for that account. Right? I want to do something like this. Total interest is equal to 0.0 for bank account, BA, in my accounts. I want to sum up the total interest. Plus equals BA dot get annual interest. Oh, wait a second. What's wrong with that? There's no get annual interest in bank account. Is there? You see it anywhere here? Well, I kind of scrolled fast, but I guarantee you there's nothing like that in here. There is in a checking account, and it uses this formula. There is in the savings account, and it uses this formula. They both have the same exact signature. So what I'm going to do is I'm going to promote that signature up to the superclass. Now it's happy over here as far as this get annual interest rate. And how can I change this list so that it can accommodate every bank account? Treat them all like generic bank accounts. And now, nice code, right? Now I don't have to worry about the details of each particular account. I can treat them all the same because I know that every account will have this method called getAnnualInterest. What's the problem up here in bank account though? Yeah, implementing it. Right? How do I don't have a formula for a generic bank account. So one thing I could do is I could return, well, a flag value, 0. And then down here in the subclass, what I've done is I've overridden, not override, override. I've overridden the behavior in the subclass to provide different behavior. We saw this annotation before when we generated this toString method. It was automatically placed there. I think I erased it just because it didn't need it at the time. You actually don't need it at all. It's not required for when you override something, but if you, it's a nice practice to do because if you are overriding a method, here I'll add something like get fee. Right? Checking accounts sometimes have fees, like say a $10 annual fee or something like that. And I say that this is an overridden from the superclass, but it's not because there is no get fee in the bank account class. Then my compiler can check me. It's a sanity check. You said that that's overridden, but there's no method in the superclass that you're overriding there. And it's going to end up with a compiler error right here. So that's why you would want to do something like that. Right? You use the annotation here. Good? Question?
So does it only, you only override something like that if the functions have the same name in each class?
Same signature. Now there is a little bit difference with covariant return types that we're not going to get into. So generally the same signature. Return type, name, and parameter list.
Does every subclass need to have that function?
Every subclass will have that function by virtue of it inheriting it, right? So if you have a bad method, sins of the father, you're inheriting that stuff. You don't have really a choice. You're going to get it no matter what. Right? Otherwise, I mean, if you don't want it, then you shouldn't have extended that class, right? In fact, we'll talk about an alternative here in a second. But in any case, you could do a default flag value here, right? Indicating, well, no interest on generic bank accounts. Or, even better, originally we did not know how to implement this. If you don't know how to implement this, then it's just an abstract idea. Right? Just like I don't know what a bank account is. I know what a checking account is. I know what a savings account is. But I don't know what a bank account is. We'll go ahead and make that abstract. Well, likewise, this method, I don't know how to do that. It's just the idea that this thing can give you interest. And how does it do it? I don't know. That's an abstract idea. So I'm going to make that method abstract. Any non-abstract subclass will actually have to specify this is how I do it, or this is how I do it. But that's creating an abstract class with abstract methods. You can have a mixture. The rest of these were not abstract methods. They actually have implementations. An abstract method has no body. It just has a signature. It's kind of like a prototype in C, right? There is this function that takes a double and returns a double, and it's called sqrt. Where's its body? Where's its actual implementation? You got to go link to that library over there. I don't know. Right? Like this. What's its actual implementation? I don't know. You got to go to the checking account and ask it. You got to go to the savings account and ask it. I don't know how to do it, right? Because I'm just a bank account. Right? Yeah, something like that. All right. So let me go ahead and bring over another diagram here. Remember this diagram of collection sets? That was just to introduce you to the hierarchy. It's actually way more complex, and even this is a truncated version of it. Right? We still have collections, sets, and tree set, hash set, array list, and linked list down here. But if you actually look at the how it actually works, there's a whole bunch more going on. We have, between it, we have this abstract collection and abstract set. That's what I just introduced you to, abstract classes. Because you can have an abstract collection. All collections have a size method, right? How much stuff is in it? That is implemented up here in the abstract collection, possibly. Right? And it's inherent because all collections would have that method. and they would all know how to do it. They'd keep track of how many things you've put into this bag, right? With some sort of a variable. And so you could implement that up here, even though you don't know that it's a list, even though you don't know that it's a set or a particular type of set or list, you still know that, well, there's going to be a size, right? So you can put that kind of more abstract stuff up here. But as you get down lower, that's when you have to be way more specific. That's when you have to start using a hash table to store stuff, or using a tree data structure, or using an array list or an array or a bunch of nodes that are linked together here, right? So we've got abstraction way up here, and as you go down the hierarchy, more specificity, right? Less abstraction. This green area up here is the pure abstraction, right? And that's why I put them all in dotted lines here, because these are interfaces. An interface is kind of like an abstract class, but it only has abstract methods. All these non-abstract methods, you can't put anything like that in an interface. Again, I'm going to put it in an asterisk there. Java 8 or 9 or something introduced default methods, which is a complete mistake in my book, but they are a thing. Just ignore them, right? Don't worry about it. So I'm just doing that to CYA, cover my ass, for anybody that says, he's wrong. You have default methods in abstract or in interfaces. Yes, you do, but let's ignore them for now, right? What are all these things? These are small interfaces. These are aspects that you can mix in to your classes. For example, the linked list down here. It is an abstract collection. It's an abstract list. It's an abstract sequential list. That just means that forget about this for now. Let's go with ArrayList because that's simpler. I don't want to get into that. So it's an abstract collection. It's an abstract list. It holds things. It holds things in an ordered manner, and it uses an array to do so. But also, it has all these things up here. You can treat it as serializable. You can treat it as clonable. You can treat it as random access. You can treat it as a deck, or actually no, that's a linked list over here, right? But you can mix these things in over here. You'll note here that the solid lines, the abstract classes, when we use the extends keyword, that locks you into this hierarchy. Right? You have a single inheritance hierarchy, so every class here has exactly one parent. One parent can have multiple children. Right? But it locks you into that hierarchy. That no matter what, the sins of the father, as you said, I forget who said that one, but you have no choice. You are inheriting everything in your hierarchy. An interface, however, doesn't lock you into a hierarchy. You can mix stuff in willy-nilly. You can, I'll mix this in. Okay, I can take that out because I no longer need it. And it won't break your tree over here. If you start and if you found out that you had a bad design and you need to cut off this tree branch right here, right, then that's going to screw up all of the other branches going down that tree. But if you've got an interface, you can go ahead and put that in, take that out. It doesn't lock you into that hierarchy. Right? There are different keywords for this, and the example that I'm going to give you is let's create an interface. An interface here, right? And I'll call this depositable, right? There we go, finish. And so you'll see here that it's a public interface. It's not a public class because it is a pure abstraction, right? And if something is depositable, that means that you can deposit money into that account or into that thing, right? So public void deposit and double amount. There we go. No body. In fact, if you try to put a body here, you are not going to be able to do this because it's an interface. It's a pure abstraction. All of its methods are abstract, right? To do. Question mark? No, you can't do this. The abstract methods do not specify a body, right? Now, I didn't write abstract, but it's implied. Public abstract void deposit. It's redundant to write that, so don't if you're going to do it. If you're going to do interfaces, right? It's okay to put that in there. It's just that it's already implied because you've got an interface up here. Right? Yeah.
Do I have to implement deposit method in every subclass?
That's the great thing about this. You have no subclasses. You are not locked into a hierarchy with interfaces, and so you can add it as however you want. For example, I could go over here to just the checking account, and it extends bank account. That locks me into the hierarchy. I implement, or implements, depositable, right? And that's going to work right off the bat. Why? Because it's inheriting that deposit method from the superclass. So it already has that method in there, that public void deposit that takes a double method, right? So I could actually promote that up to the, did I do that in checking account? Yeah. I could promote that up to bank account, and all bank accounts implement depositable. Would that be a good idea though? Can you deposit money into a loan? You could pay a loan, so and that's kind of like a deposit, but it's a completely different word, and it's different and distinct enough of a concept that I probably would not want to do this, right? I'd want to go maybe back to the drawing board and maybe think of an even larger hierarchy where I've got bank accounts, deposit accounts, loans, right? And then I would make all the deposit accounts depositable, but not all the bank accounts, right? Something like that. But I'd say Yagni, right? Remember Y-A-G-N-Y? You ain't gonna need it, right? Cross that bridge when you get there, right? Do we need to do loans? Not for this exercise right now. Yeah. Exactly. Like we could have nameable, right, or ownable, right? And then we've got some bank accounts that necessarily have an owner, but then other bank accounts that are corporate accounts and they don't have an owner, they have an entity, or whatever your business needs are, right? It's kind of I show this picture because this is a perfect example, right? Collections is a perfect example. The examples that I try to put together are all fake examples. It's really difficult to find a real world example to illustrate this stuff on. And when I do, I make that into a project instead of using it. I need to find a much better example. This is as close as I can get, though. Yeah.
So like, you lost me after you put up the big sheet.
Okay.
What's the big idea here with like the depositable? Like, how does it know what to do with that, and not just be like, well, that's an empty interface. Like that's nothing.
Well, you can have, actually there are empty interfaces. I think random access is an empty interface. That it's there to illustrate, to give an array list an aspect. An array has random access. If you want to go to the fifth element in the array, all that is a memory offset. So you can immediately jump there at no cost to you, or at very, very little cost to you. Other collections are not random access. Tree set, you can see here that random access only goes to one of those. So if you want, you can check, is this a random accessible collection? Tree set is not. So you would not be able to do any tricks that rely on that aspect. Another example here would be your lab tomorrow, right? Let's look at that. And I'll zoom in here. There we go. So we've set up a hierarchy that you have to reproduce. We've got employees, right? Then there are hourly employees and salaried employees. And if you look real close here, you can see a hint as how to implement these things. That's a class, but there's an A right there. What do you think that A stands for? Abstract. This is an abstract class, but it has several concrete methods here. If the font is normal, then those are actual methods that are implemented in that class. If the font is italicized, and there's an A here anyway, that's an abstract method, right? This is also an abstract class, and it's only when you get down to the bottom here that you have an actual class, a temporary worker versus a staff worker, and then they have the way that their taxes are computed is different. But otherwise, the way that this person's taxes is computed is different, etc. All those methods are inherited, but they're abstract methods that you have to implement down here. Now, way up here, we introduce at the end of the lab a supplier. A supplier, you also pay the supplier, right? But you don't collect taxes. It's not an employee. You're not paying them for services. You're paying them for goods, right? That you can use to build your product or whatever. So what we have is, well, we made this interface above it that's payable. And payable only defines one method, get net pay. How much do you have to pay this supplier? How much do you have to pay this employee, right? And all of these entities are payable. Right? Does that help? Or yeah, go ahead.
I still don't get, like, is an interface basically just like a description?
An interface is like a prototype in C. An interface says that if this class is payable, then it has to have this get net pay method. And if it doesn't, then compiler error. Right? The interface that I made over here, depositable, says that if this class is depositable, it has to have a method named deposit that doesn't return anything that takes a double as input. And if it doesn't, like checking account, well, checking account is going to have it by virtue of the bank account up here. If I got rid of it, though, everything else breaks, right? Because over here in checking account, you're saying that, savings account, oh, what happened to it? Did I get rid of it? Implements. Deposit double. There we go. Oh, yeah, I put it up here, didn't I? I'll get rid of it here. But now savings account breaks because bank account doesn't break because it's not implementing that interface. But checking account breaks because I said that it implements that interface, but I lied and I didn't provide the actual implementation, right? So it's kind of like in C when you have a prototype and you say there's this function out there called get net pay, and then you never actually define it. The compiler is going to say, okay, well, you can use it over here. I know I'll compile the code that calls that function, but at the end of the day, if you want an executable program, I have to have an implementation. You didn't give it to me, so I'm not going to be able to compile. Likewise here, this says that it's depositable. You have to have this method that is that's called deposit, and it's not right here. Let me roll this back so that it actually compiles. Yeah, go ahead.
You can't create a array list deposit.
Yes, you can. You can create an array list of any type, including interfaces. So we could go back over here, depositable, and it'll allow that right now. But oh no, it won't allow that because bank account itself is not depositable, right? But you can create a list of it. Line 32 is perfectly fine, right?
So for the interface payable, can you make that an abstract class instead?
You could, but then how would you? So the question was, can you make payable this interface? I don't like interfaces. I like abstract classes. Let's make this into an abstract class. It would still only have one method, and that method would still be abstract. So it doesn't buy you anything on that way. But also you've lost something. You've locked yourself into that hierarchy now, right? Not only that, but if you ever want to make anything that is also payable that has nothing to do with supplier, employee, et cetera, right? That's going to lock you into that hierarchy. And once you're locked into that hierarchy, that's it. Now you make all. Now you build. Now you have 15 years of code built on that initial design. And if you ever go and try to change that initial design, and you've locked yourself into that hierarchy, everything else is going to break. So you have to get a good design up front if you're going to lock yourself into that hierarchy. Or you can use interfaces as much as possible that doesn't lock you into that hierarchy and that does open itself up for changes in the future. This gets to something called the solid principles that we'll talk about later on. Single responsibility principle, open closed principle, Liskov substitution principle, interface isolation. That's the one for this. That you want interfaces to be small. You want them to be pure abstractions. You don't want any default behavior. And that's why I think that default methods were a mistake in Java, because that ends up, It doesn't lock you into the hierarchy, but it certainly locks you into certain behaviors. All right. Let's see, what else? Okay, so another, I could save, I'll save that for next time since I didn't do it in the main section either, but yeah. No questions online. Any questions as to this stuff so far? Yeah, again, we're not expecting inheritance in phase 2. If you want to do it, great. If you want to work ahead and design it that way, great, go ahead. But we're not expecting any subclassing at all in phase 1. Phase 2 certainly should be there. And by now we've done enough that you can get started on phase 2. Certainly you should be finishing up phase 1, of course, first. We're looking for good encapsulation, good abstraction, and good composition. And of course it has to work. So those are the things that we're looking for as far as design goes in the first phase. Question?
Should I be having interfaces and spaces?
No, that's inheritance. That's all part of inheritance. I mean, eventually if you want to, you can. You don't have to though. In fact, there are going to be at least a half a dozen different variations on the inheritance, maybe some abstract classes, maybe some interfaces. You could have an entirely copied interface like this does, the hierarchy like this does over here. Set, collection, list. That entire hierarchy right there is repeated right here, but as abstract implementations, right? So you could do something like that for your project. That's going a little overboard, I'd say. But to have interfaces and abstract classes is probably a bit much. But go ahead, play around with it. It's certainly not wrong. It's just that Yagni, you ain't going to need it.
So like the first phase is going to be pretty basic. Like you're looking for.
It's just EDI. Make sure that you've got your basic classes up and running. Make sure that you've got your parsing. Make sure that you've got your persistence to JSON and or XML. And that's another thing that you should think about. Good composition, good encapsulation means separating concerns. So we haven't talked about the solid principles yet, but the first acronym, first word in that is single responsibility. Your square root function. Does the square root function compute the square root and the sine function, and it logs a bunch of information, and it does your laundry for you? Now, what does it do? It just computes the square root function, right? So what about a class? Should a class be responsible for bank account stuff and person stuff and address stuff? No, a bank account class should just be responsible for bank account stuff. Likewise, should think about the process of your first phase. You're going to be loading up data. You're going to be creating classes. You're going to be saving data to XML. So loading up data, creating your classes. You're going to be saving data as XML. You're going to be saving data as JSON if you choose to do both. Hopefully you choose to do both because it's super easy, right? How many concerns does that sound like? At least 3, right? So how many classes do you think you should make? Probably at least 3, right? Single responsibility, right? Now, one class that loads up data, that could be responsible for items and stores and people, right? That's fine. That's not, it's just loading data, right? You have to, at that point, it becomes more art in the design because you know, when I say it has a single responsibility or single concern, what does that actually mean, right? And deciding that, well, all data loading is one thing, or data loading of stores and data loading of items, those are different things. You can go that route if you want to as well, and that's not wrong. Both of those things are right. It's just how much work are you going to put into the design? How complex is it going to end up being, right? The complexity can be a good thing because setting up a bunch of dominoes it can be very, the domino compositions or giant towers of dominoes, and then you hit one domino and they all fall into place, right? Complexity can be good if at the beginning all it takes is one domino and they all fall into place. But if you have one domino and then it all falls apart, that's not good complexity. Complexity can be good, complexity can be bad. Design can be good, design can be bad. Right? And there are obviously bad designs, there are obviously good designs. It's everywhere in the middle that we can start having a healthy debate with your partner or your rubber duck about. Right? Any other questions? No? Oh yeah, go ahead.
I was having trouble understanding what you meant by the hierarchy and what that means. Like you said, like it locks you into this hierarchy. And
So let's say that I put in a method up here in the abstract collection called, I don't know, let's see. Here's a bad anti-pattern. Remember that there are multiple concerns. An abstract collection, you can add stuff to it, right? That's going to be an aspect of all of these collections. So maybe there's an add method up here, right? That means that's going to lock you into the hierarchy in that everything below this is going to have an add method, or eventually, right? The tree set has an add method. The hash set has an add method. The array list has an add method. Now, what if instead I did, so that seems reasonable, add. And then there's just this element, item. I won't even type it right now. Right?
yeah.
What if I said add to index? And then I provided an index I and the item. Should I put that up in the abstract collection up here? No, why? Because that would break my notion of a set, right? But if I had done that, say that I lived in a world where I never even thought of sets, right? So I put that add to index up here in the abstract collection. Now I discover sets. If I put that into this hierarchy, I've already locked this hierarchy in by putting this up here. I can't add the notion of sets anymore because of my mistake of putting something like that up higher in the hierarchy. Right? Certainly you have something like this in abstract list, and that will lock everything that is a list into that hierarchy, but it doesn't lock everything over here. Right? So be careful. Only put stuff into the superclass that you know every subclass will have that aspect. Right? That's what might lock you into the hierarchy for years to come. If you design a hierarchy one way, then that forces you to do a whole bunch of other things. For example, here's another example. Depositable, public, void, log transaction, and then whatever. I've put two abstract methods into this depositable interface. That locks me into a hierarchy in a different way. If you want to make something depositable, like we do over here in bank account, let me restore that. Implement depositable. There we go. And get rid of this. Are you happy now? Or I thought I had deposit here. It is. So what are you complaining about? Oh, there, no, okay. Exactly what I was trying to demonstrate. All right, so they both have this deposit method. But now I am forced by this interface to also do log transaction. I don't want to do that. Maybe I'll do that for checking accounts. That seems reasonable. But now over here in savings accounts, I don't want that behavior, right? But it's locked me into it because I've said that this is depositable. And that goes to the I of the solid principles, that interfaces should be as small as possible. Most interfaces are only ever going to be one method, and that's it. Right? That's what allows you, or zero methods, right? Some of these over here are just aspects and don't even have a method at all. Right? Like random access has no methods in it, I believe. Right? That's the interface isolation principle. Or we'll have to review it when we get to solids, the solid principles. Okay. All right, we'll go ahead and continue there next time then.